Hello friends, today our discussion topic is deck seal. Okay, so this deck seal is normally found on oil tankers. Okay, so this in oil tanker, deck seal is a part of inert gas system. Okay, so inside this inert gas system, why do we need a deck seal? Okay, so let's assume there is no deck seal at the moment in the inert gas system. Okay, so this is our engine room of the ship. Okay, here there is a inert gas production system or IGS system is there. So from here inert gas is produced and supplied to the deck or main deck where the cargo tanks is located, and this inert gas is supplied to all the cargo tanks where inert gas is inerting is required. Okay, so this inert gas system is fitted with lots of valves to prevent access gas flowing inside. Okay, so whenever this inert tank system is inoperational, it is not working, so this valve will kept closed. Okay, so after closing, what will happen is in the cargo vapors, okay, hydrocarbon vapors, okay, whatever the mixture of vapors inside the cargo tank, it is in a pressurized state. So it has a tendency to go back to the pipeline from where it has come to the tank. Okay, so to prevent this going back of hydrocarbon gas, there is valves are fitted, manual valves and automatic valves. Okay, so one of that valve is non-return valve, NRV. Okay, so whenever there is a backflow, that non-return valve will remain shut and will not prevent any access of gas backwards. And there is also a one manual valve in case this inert gas system non-return valve fails. This manual valve also has to be there. So this is the principle of going and coming back of gases. So let's assume the inert gas system of the cargo ship is delivering inert gas to the cargo tank. Okay, so as I told earlier, there is a non-return valve and manual valve manual valve in the system. So during the delivery system, all these valve will remain open. Okay, so all these NRV, okay, NRV and manual valve, okay, manual valve has to remain open, but unfortunately due to some technical problem, this inert gas system shut down. Okay, so suddenly we don't have the time to go and shut the manual valve. It will take some time to shut the manual valve, and the non-return valve, it will shut automatically, but it is a moving part. So over the period of time, if something happens or to the valve, and if there is any damage, okay, or if there is any leak in the valve, there is a chances that the hydropressurized hydrocarbon gases will enter inside, pass through this valve and bypass, and there is a tendency that it will reach the engine room area. Okay, so as soon as this hydrocarbon reaches the engine room area, we know hydrocarbon is a good fuel for fire, right? Okay, so in engine room, all other two components like oxygen and heat is there. So automatically fuel is there, oxygen is there, heat is there, so the fire triangle is complete. So fire will be initiated, and it will contain make a chain reaction. Finally it will explode, engine room will explode. So to avoid that thing from happening, so our technical geniuses in maritime history and research people, they decided that there is some kind of a barrier between this cargo space and the engine room area. So that should work independently, okay, independent from all the manual controls or non-return valve something. It should not it should be maintenance free, okay. So they come up with an barrier. So that barrier is called deck seal, okay. So after the deck seal, we have now the manual valves, okay. Then we have the non-return valve. Then behind the deck seal, we have the engine room, okay. So this deck seal is like a protective barrier between engine room and cargo area. So in cargo area is having a hydrocarbon area, the hydrocarbon vapors, so that is very dangerous gases. So inside the engine room is considered as safe place, okay, no hydrocarbon vapors. So the purpose of deck seal is to act as a barrier between the safe place and unsafe place, okay. That is the purpose, and this deck seal was introduced. Now in the next slide we will discuss how many types of deck seals are there in the industry, okay. So types of deck seal, okay. So there are three types of deck seals available in the industry. First one is wet type, okay. The second one is semi dry, okay. The third one is dry type, okay. So among the three, first we will discuss working and the in cross section and construction of wet type deck seal, okay. So uh, so the principle of this wet type deck seal is the liquid, okay. There is a liquid inside the deck seal. So this liquid is displaced by the gas, okay. So the ability of a gas to displace the liquid inside a cylinder, that is the principle practically used for the working of this wet type deck seal. So now I will draw the deck seal construction of wet type, okay. So this is a pipeline coming like this, okay. So in this pipeline is going inside the deck seal, okay. So from deck seals construction there is one more, okay. Okay, so okay, so our inert gas from the engine room will enter inside the deck seal through this inlet pipe, okay. So this small box type thing is called deck seal. So inside this deck seal water, okay, our normal sea water is filled, okay. So this sea water is filled in such a way that where this pipeline, okay, this pipeline is slightly immersed, okay. So the opening of this pipeline is inside the water level, okay. So below also water is there, okay. This in normal condition when the inert gas system is not working, and the level of water inside the deck seal should be slightly above the opening of the inlet pipe, okay. Okay, so and there is an outlet pipe inside the outlet going out of the deck seal, okay. So whatever the inert gas coming inside the deck seal has to go out through this pipeline, okay. Okay, so there is one another thing is also there in before the outlet pipe there is a demister pad, okay. Okay, so what actually happens here is when the inert gas is coming through the uh, inert gas system or inert gas plant, so all this gas will reach the in a deck seal, and when the gas reaches the deck seal, at this region there is water, okay. So this gas cannot go outside from the pipe. So when there is a little more pressure in the inert gas inlet side, the gas will push the liquid away, okay. So the gas will push the liquid, and the water will be displaced, pushed away from the opening of the pipe, okay. So when the water is pushed away from the pipe, what will happen is this inert gases will escape through this pipe, okay, escape through this pipe, and it will go to towards the demister pad, okay. It will escape from the pipe after displacing the water and go to the demister pad. From this demister pad, since it is escaping through the displacing the water, but some of the gases will be bubbling through the water also, okay. So this water content, this gas may have some water content. That water content will be cleaned by this demister pad, okay. After that this gases which passed through the demister pad will escape through the IG outlet of the deck seal level. From this place it will go to the manual valves, okay, manual valve. Then that valve, after opening that valve, it will go to NRV, okay. Then finally go to cargo tank. Become malfunctional or not working. So for that I just have to erase all these arrows, then only I can explain, okay. Okay, okay, let's assume the inert gas system is stopped, and there is a sudden backflow of IG from the cargo area, and these two valves are not working. So the IG will try to enter the deck seal through the pipe. It went inside the cargo tank. It will again, since it is a gas, it will easily pass through the demister pad and reach till this area, okay. So another important thing is when the inert gas system is stopped working in a wet type of system, the water level that I initially told, as soon as the gas flowing through this system stops, the water will remain to the normal level. Okay, by submerging the opening of the pipe. Okay, so when the gas comes back from the cargo tank, okay, what will happen is this gases apply pressure on the surface of the liquid. Okay, so what will happen is this liquids or liquid or water will be pushed inside the pipeline. Okay, so so whatever liquid inside the deck seal will be pushed inside the inlet pipeline. So even if the return IG gases somehow tries to manage the demister pad and all those well, this pipe cannot the gases cannot enter inside this inert gas inlet pipe and go back to the engine room area. Okay, so as soon as the water level is pushed below and some water level goes inside, so what will happen, there is a inlet pipe for supplying seawater to the deck seal. Okay, okay, so this inlet pipe will keep on pumping. So whenever the some amount of water is going some amount of water go inside this pipe, the normal water level of the deck seal will reduce. Okay, so to maintain this water level to normal level, okay, so the seawater pump of the deck seal will keep on pumping the water. Okay, so the excess water will be thrown out through a outlet pipe. Okay, like an seawater inlet, there is an seawater outlet pipe. Okay, so the purpose of the to properly working the deck seal, to all the time seawater level, okay, has to be maintained. Okay, so to maintain this seawater level properly, there is a inlet pipe and outlet pipe of seawater for the deck seal. Okay, so when the air gas sorry not air the inert gas pushes the water level downside, so some more the water level drops. Okay, some water level will go inside from the initial quantity. So to further maintain that level, more and more water will be pumped inside. So no matter how many times the inert gas push the water, okay, sorry, push the water, only the water will be going inside the IG system, no hydrocarbon gas. So whatever the amount of water inside this deck seal reduces, more and more water will be pumped inside the deck seal. So under no circumstances the gas will not go inside the inside the engine room area through this inlet pipe. Okay, so to maintain that proper level and quantity of water all the time, so there are deck seal seawater pumps. Okay, there will be two pumps always ready for supplying seawater to the deck seal. Okay, so when this pump is not operating, as a standby we have another pump in the deck seal. Okay, so these deck seal pumps will be there to work over there to maintain the water level. So during the operation time, okay, like I told, when the gas is passed through the inlet pipe, okay, the water will be displaced. Okay, I hope you remember what I told in the beginning. Okay, so during that time some of the water level, okay, some of the water level will be some quantity of the water, the amount of water displaced by the gas will be thrown out through the our seawater outlet, so that that particular level will be maintained. Okay, so what to counteract the loss of water, the more seawater is pumped through inlet. Okay, so during the operation of IG system, one of the deck seal seawater pump will be running continuously till the time the operation IG inert system is working. Okay, okay, so this is the working principle of a deck seal. Okay, so when the IG gases comes to the deck seal from the engine room, it displaces the water and bubble through the water, or slide away the water and go to the cargo tank. When the IG gas returns from the cargo tank, it will be pushed by the inert gas, and the water inside this pipeline or the inside the deck seal will be filled inside the pipeline. So no more chance of inert gas going inside the inlet pipe and going to the cargo tank. Okay, so this is about wet type deck seal. So another type of dry and semi-dry, I will make another video. This video is almost 22 minutes, and I will make another video of that thing. So I hope you guys understood what I am trying to say here. If there is any doubt, you can go to isgot, you will get all the information there. Okay, about the working principle of and the diagram of the deck seal. Okay, or if you refer a book, safe tanker operation. Okay, okay, in that book also everything is given. Okay, by Captain KSD Mistry. Okay, so I will show the for better understanding two different diagrams of the deck seal in during a delivery system or delivering inert gas, and when the backflow time. Okay, just a moment, I'll go. So this is how the deck seal looks in normal mode. Okay, water level is in the normal mode, no gas is flowing through. Okay, so when the gas is flowing through the deck seal in the forward direction, that means going towards the cargo tank. Gas to flow of gas to cargo tanks. Okay, in this time gases will be passing through all this inlet pipe, and it will displacing the water. Okay, and going to demonstrate and going to cargo tanks. Okay, there are these two alarms that I didn't mention earlier. This is a low level alarm and high level alarm for the seawater pump. Okay, and so when the water level is very low, and it will give an alarm to the CCR operator. That means something wrong with one of the pumps, so we can automatically suddenly switch on the another pump. Okay, this is a high level alarm. When in case this drain valve is choked, okay, what happened, the water level inside this tank will keep on filling, so water will also go inside the cargo line. To avoid that, this high level alarm is also given. Okay, so this is the condition when the inert gas is backflow. Inert inert gas backflow condition. So the inert gas from the cargo tank is coming back, okay, passing through demister, and it is applying pressure inside the pressure on top of the water. So all the water will rise in the inlet pipe and block the inert gas going towards that. So whatever the in the amount of water go inside the bend inside the pipe will be refilled by this seawater pump. Okay, whatever the excess will be gone out. Okay, that is how the water level is maintained. So this is all about the wet type deck seal. Thank you friends. Bye.